So this is the 2016 Junior Cert Higher Level Paper 1, and we're looking at question 13. The right angle triangle ABC is shown in the diagram below. The square BDEC is placed on the hypotenuse of this triangle. The area of the triangle ABC is 12a squared square units, where a is an element of the set of real numbers. The length of the side AB is 6a units. So we have a diagram of said triangle underneath, and the question says find the area of the square BDEC in terms of a squared. So we're looking for the area of this shape here. We want to know the area of this, and our answer can have a squared in it. If it says it's in terms of a squared, we're allowed to have a squared in the answer. So we're looking for this area. Okay, well, this is a square. It does say it's a square, so the area will just be the length by the width. Okay, so that's what the area will be. Now, the first thing we need to realize is, well, this is a right angle triangle, so we may have Pythagoras involved here. Now, they give us the length AB as 6a, and they give us the area of the triangle as 12a squared. So, if we can find this side here, the side AC, then we would be able to use Pythagoras to find the square and the hypotenuse, which would be the area of the square we're looking for. So what do they tell us? Well, they tell us the area of the triangle is 12a squared. Now, the formula for the area of a triangle, it's in your tables book, but there's a few formulas for it, but the one we're going to use is this. The area of a triangle is a half AH, where A is the base and H is the perpendicular height. Okay, so we know that the area of the triangle is 12a squared from that formula. So we're going to set up this equation. We're going to say the half of A, so A is the base, and that the base of our triangle is 6a. So a half of 6a multiplied by the height, let's just call this here h. So the half the base by the height h is equal to the area of the triangle, which we know is 12a squared. So that's the first equation we've set up. And we're going to use this to find what h is in terms of a squared. So first thing I'm going to do here is I'm going to square both sides. I'm going to double both sides to get rid of the half. So when I double both sides, I'm left with 6ah here. 6ah is equal to 24a squared. Double the half becomes 1, and double this gives that. So then I know that if I just want h on its own, I'm going to divide this side by 6a. If I do that to the left, I'm going to do it to the right. Now, why do I divide by 6a here? Because 6a and 6a cancel, leaving me with h is equal to, now here I can say that 6 goes into 6 once, 6 goes into 24 4 times, a goes into a once, and a goes into a squared 8 times. So I'm left with h is equal to 4a over 1, which is just 4a. So I found h is 4a, so I now know that this here, 4a, is h. Okay, so now I can apply Pythagoras to find this side. So this side here, the square on this side, which would be the area of the square. If I call this y, Pythagoras says the square and the hypotenuse, y squared, is equal to the sum of the squares on the other two sides. So it's equal to 6a squared plus 4a squared. And it's all of 4a squared. Make sure you put it in brackets. Same with the 6a, they have to be in brackets. So that gives me y squared is equal to 6a squared, so 6a by itself, 6a by 6a is 36a squared, and 4a by itself, 4a by 4a is 16a squared. So we get y squared, which is equal to 36a squared plus 16a squared is 52a squared. So if we don't even need to find y now, because y is not actually what we're looking for. We're looking for y by itself to give the area of the yellow square. So y by y, which is y squared. So we've actually found y squared, and it is in terms of a squared, which they asked. So the answer is 52a squared. And that's the end of the question.